The food system accounts for a substantial use of natural resources and is a major contributor, among all human activities, to the environmental degradation. It contributes between 20 and 30% of the total greenhouse gas (GHG) emissions, accounts for 70% of all fresh water use, and is a major source of water pollution. Steinfeld et al., 2006. About 80% of the world's deforestation is related to the food system, and it is the leading cause of land use change and biodiversity loss. Tucker et al., 2006. Attention has been mainly focused on the production of food, which has been considered to be the phase of the food system with the highest environmental impact. De Monte et al., 2005, Weber and Matthews, 2008. The general population is increasingly conscious of the consequences of food production on the environment. In 2018, 6 in 10 consumers say it is important to them that the food they purchase or consume is produced in a sustainable way. This shows an increasing trend over the past 5 years. International Food Information Council Foundation, IFICF, 2018. Above 40% of the U.S. population reported recently that sustainability is the main factor guiding them in their food and beverage selection. IFICF, 2018. Nevertheless, to obtain an overview of the global sustainability of a product, the entire food supply chain should be considered. Nowadays, 78% of the U.S. population consumes packaged foods. IFICF, 2017. Food packaging plays important roles in the food system, such as protecting food products from contamination and damage, reducing food wastage, and providing consumer information. Marsh and Bugaz, 2007. Traceability, convenience, and detection of food tampering are secondary functions of increasing importance. Food packaging is approximately 50%, by weight, of total packaging sales. Marsh and Bugaz, 2007, and accounts for almost 2/3 of total packaging waste by volume. Hunt et al., 1990. From the consumer's point of view, the main reasons to buy packaged foods are convenience, time saving, and ease of meal preparation. IFICF, 2017. In fact, over 54% of those interviewed said that convenience and food that is quick and easy to prepare are the most important factors, especially when talking about breakfast. Date Essential, 2014. Manufacturers of breakfast products should take into account not only the home-consumed products but also the need for speed of pickup and portability of the takeaway options, in order to satisfy consumer desires. Board Buyer, 2016, NDP Group, 2016. Breakfast meals, at and away from home, are forecast to grow by 5% through 2019, NDP Group, 2016. The majority of the breakfast products are presented in a variety of packaging materials and sizes, which may be expected to impact the ecosystem in different ways. The United States Environmental Protection Agency, EPA, encourages consumers to buy packaged products that have a reduced impact on the environment compared to other products that serve the same purpose. However, the literature discussing the environmental impact of food packaging is scarce. Therefore, our goal was to perform an assessment of the environmental impact, specifically GHG emissions, of the materials used for the primary packaging of commonly consumed packaged foods, specifically breakfast products, and to determine whether the size of the products has any effect. Additional objectives included whether different types of packaging materials for the same type of food product impacted the environment differently. 2. Whether the same commercial food product packaged in the same type of material but marketed by different brands have different environmental impacts. 3. The relative environmental impact of the packaging compared with the entire food production. We also performed a sensitivity analysis to check the generalizability of our findings in relation to other environmental impacts. 2. Materials and methods. 2.1 Selected products. The food products evaluated in the current analysis were those typically consumed in a continental-style breakfast: orange juice, milk, instant coffee, breakfast cereals, bread buns and peanut butter. All products were purchased in September 2018 at two popular supermarkets in South California, i.e. Stater Bros and Walmart. Therefore, the characteristics and quality of the packaging met the requirements for sale. The assessment of the packaging for each type of product was undertaken for 3 different product sizes. One product comprised of single packaged servings, and the other 2 comprised of multi-serving products, although in different sizes. All the assessed packaged foods of a specific type of product that appeared in different sizes were manufactured by the same brand. For confidentiality, we designated this brand as Brand A. Brand A is specific for each food product, varying among different foods. Table 1 provides information about the selected products. The reported data for each food product includes the food, the number of servings, the serving size, the parts of the packaging measured, the packaging material and its weight. The number of servings and the serving size were obtained from the label. For some of the selected products, i.e. orange juice, 4 servings, milk, 4 servings, and peanut butter, 14 servings, alternative packaging materials were assessed. This included cardboard, plastic and glass for orange juice, cardboard and plastic for milk, and plastic and glass for peanut butter. Table 2 shows information of these alternative products. Food, main material of the packaging, size, serving size, part of the packaging measured, the type of packaging material and its weight. Of the products described in Table 1, one size was selected as a reference for each product: orange juice providing 4 servings, milk providing 8 servings, instant coffee providing 120 servings, breakfast cereal providing 16.5 servings, bread buns providing 6 servings, and peanut butter providing 14 servings, in order to compare with the same type of food, produced in the same size and in the most similar material, but manufactured by different brands. 2 alternative brands were selected for each of these products: brands B and C. Brands B and C are specific for each food product, varying among different foods. Table 3 reports the food, the brand, the size of the container, the serving size, the part of the packaging measured, the type of material used and its weight, for each of these alternative products. 2.2 Assessment of the type of material and weight measurement. All parts of the primary packaging were accounted for. The samples were carefully opened and emptied. The packaging was divided into all individual parts. Each part was meticulously cleaned. For some parts of the packaging, the type of the material used was reported on the packaging itself. Otherwise, the assessment was done in accordance with literature focused on food packaging that reports the most commonly used materials for each part of the packaging and the previous experience of the authors. We assumed that packaging materials have not been reused or recycled unless stated on the packaging itself. The weight of the packaging materials was estimated using a and DGF 300 scale. The weight of glass containers, for which the weight exceeded the capacity of a and DGF 300 scale, was assessed using Sanjama SCDG 33BK scale. To handle any potential error in the estimation of the weight, each part of the packaging was measured 3 times, from which a mean was calculated. Tables 1, 2 and 3 show mean and standard deviation, SD, of the measurements of each part. 2.3 Life Cycle Assessment, LCA. LCA is a quantitative method for evaluating the impact of products, processes or activities, such as food production and manufacturing, on the environment. Heller and Kilayan, 2011, Sanders et al., 2003. Venkat, 2012. LCA may be used for the from cradle to the grave perspective, but may also be used in a limited perspective, from process to process, which can be of particular interest when carefully analyzing a limited part of the whole life cycle.